This is the tutorial for the second day of Chapter 8, Section 6, factoring trinomials in the form of ax squared plus bx plus c. So a little tougher problems here. So one thing I'm going to always look for is common factors. See, 8 and 42 have a common factor of 2, but 2 does not go into 27. But one thing I can do is I can't make these numbers smaller, but I can use the last digit sign to help me out. As long as the first term is positive and the last term here is positive, I know that the outer terms and inner terms are going to add together to make a negative 42k. And so that tells me something about this. That tells me that I'm going to have two minus signs. Next thing I see is that 42, since the numbers have to add to make 42, if I don't break down the 27, I'm going to end up having to multiply 27 by a factor of 8. The only factor of 8 that won't make it bigger is if I end up using 1 as the factor. So that would have to be 8 times 1. And 8 times 1 and 27 times 1, 8 and 27 don't add to make 42. So I know I need to break the 27 down. I'm going to break it down to 9 times 3, the other factors that make 27. Now I'm going to think of 9 times a number. I don't want to make it bigger than 42. So 9 times by 4 is a factor of 8. So I'm going to list some factors of 8. I'm going to do 1 and 8, and I've got 2 and 4. And I look at those factors, and I need to make the numbers smaller than 42, the product of some of these factors. So I'm going to try 4k here and 2k. And if it doesn't work out, then I'll try something else. So this makes negative 36k. And this makes a negative 6k, and those two do add together to make negative 42k. Yes, that does end up working out. So I check, I know the first terms multiply to make 2k squared, and the last terms do multiply to make a positive 27, so it does work. So this would be our answer. Now this one looks really tough because the numbers are big, but don't get stuck thinking, oh, I need to deal with these huge numbers, because if you can take out a common factor, it makes the problem a whole lot easier. Sometimes you'll be able to do it, sometimes you won't. So here I see I could take out a 4 from each of these terms. So I'm going to go ahead and do that. And now I'm left with some easier numbers. 10k squared minus, and then 4 goes into 136, looks like 34 times. And then I've got the minus 4 goes into 96 24 times. And so now it's a much easier factoring problem. So I still have somewhat difficult time here because 24 has a bunch of different factors and I need to subtract. So I don't know the signs of which one goes where. So I'll have to figure those out later. So we'll start off by trying to find numbers that subtract to make 34, but yet multiply. The last terms multiply to make that 24, and first multiply to make the 10. So my guess is I need to break the 10 down. I don't think I'm going to multiply 10 times one of the factors, but you never know, you might. But I'm going to go ahead and just list 2x and 5x as the factors of 10. Now, for 24, I'll list all those factors. 1 and 24, 2 and 12, and I've got 3 and 8, 4 and 6. So it's good to list these factors and try them. And so basically you're taking these factors like 4, multiplying it by 5, and then doing 2 times 6 and seeing if those subtract to make 34. Well, since they have to subtract, we want one of the factors to be bigger than 34. So my guess is I need to multiply 5 by one of these numbers to make it bigger than 34. So 5 times 4 is not going to make it bigger. 5 times 6 doesn't make it bigger. 5 times 3 doesn't work. So the only numbers I could multiply by 5 would be 8, 12, and 24. So I'm going to start with this one right here. And so I'm going to try to multiply 5 by 8, and I'll put the 3 right here and see what happens. So this is 40, and this is 6. And yes, those do subtract to make 34. Now to make it a negative 34, I need to make 40 negative. So the minus sign has to go here to make it a negative 40. And I end up getting a positive sign right here, and that does end up working out. So you can see how we get negative 34x. We've got a 10x squared. And we also have a negative 24. So that matches what I have up here. Just need the 4 on the outside to make it all work out when you multiply it together. So those are those types of problems. Let's take a look at other ones that we might end up seeing. And here we have the area of a rectangle computer screen is this. The width it gives us is 2x plus 8. So if they didn't give us the 2x plus 8, then we'd have to go ahead and factor. But look at this. We see that there's common factors. To make this factoring easier, You could have divided everything by 4 in this case, but I'm going to leave it as this expression because they gave me 2x plus 8 is one of them. So now I just need to find out the numbers that make this. Well, 2x times 2x makes a 4x squared, and to make a 16 I'll need to multiply by 2. Let's see if it works out. So 8 times 2 again makes 16. Let's check the middle terms, or the inside and outside terms. So I got 16x and 4x. Yes, those do add to make 20x, so it does end up working out. So this, our length would end up being, in this case, 2x plus 2. Again, if you had to find the length and the width, then you're just going to have to factor the whole entire thing. So let's practice that with this one here. We've got another one that gives us a rectangular granite countertop is this expression. It gives us the width. So if we didn't have the width, we'd have to find both. So in this case, again, you can look to see, you can make the factoring easier, take out the common factor of 2 if you needed to. But in this case, since they gave us the 2x plus 3, we'll go ahead and use it. And to make a 6x squared, or 12x squared, I need to put a 6x here. And to make it a negative 12, I need to do 3 times minus 4. And let's see if it works. So this makes 18x. This makes negative 8x. Yes, those do add to make 10x. That's what we have right here, so I know it's correct. So we would say the length equals, and we'll go with a 6x minus 4. And do they have any units there? So let's go ahead and stick some just units at the end. Same thing over here. We'll just put in units at the end. I'll erase my line here and write in units at the end. So those are the types of problems that we're going to end up seeing on tonight's assignment. Good luck.